Tom.
Cool. Everyone hear me? Anyone want to hear me?
Yep.
All right, fair enough. Okay, I haven't done this with a microphone before, so it's all going to go terribly wrong. As you said, my name's Tom. I work for a company called PodPoint. We do electric vehicle charging sockets. I spend most of my time working out how, when everyone buys a car, we're not going to set fire to the national grid. But I'm not going to talk about anything as important as that today. Today, I want to take you back to 1993. Jazzy Jeff and the Fresh Prince have declared that it's summertime. Robin Williams is taking a dubious approach to custody of the children. And Jeff Goldblum is teaching us that life finds a way. But most importantly, ID Software are releasing their seminal title, Doom. Probably, as you can tell, the most important game of all time. With its realistic graphics, immersive multiplayer, and deep emotional storyline, which I'm sure sticks with us all to today. Just in case there's a few of you who are too young, or maybe old enough not to have wasted your youth playing it, Doom is a game where you shoot things while you avoid getting shot at yourself. And maybe because it's 30 years old, maybe because it's written in some quite impressive C, it's been ported to pretty much everything. You can play Doom on a digital camera, you can play it on a thermostat, you can play it on a potato-powered calculator, a pregnancy test, you can even play it in Sonic the Hedgehog. And because it's been ported to everything, it's become the sort of de facto platform maturity test, which is to say, when someone comes to me with a new piece of tech that they want to integrate into the stack, I'll say, sure, it might be half the price and solve all of our problems, but before we put it to production, I want to know, can you play Doom on it? Now, something of my credentials, I've been using AWS for about 8 years now, which means that I've pretty much grown my AWS wings off the back of serverless. In fact, it's got to the point where when I see an architecture diagram like that, stitching together 100 different services to deliver Facebook for cats, I say, yes, that's exactly how I would do it. But, you know, I still see a lot of hesitancy in adopting AWS and serverless, and I think there's a pretty clear reason for that. They haven't delivered a serverless version of Doom yet. And so today, I'm going to fix that problem. So, I don't know about you, but when it comes to migrating a load onto AWS, or if you're lucky enough, starting a new project, I like to start with the Triforce, your Lambda, your S3, and your DynamoDB. I'm telling you now, you can deliver about 90% of all applications using these free services alone. So, Doom. Hopefully it's not too controversial, but we're going to be using Lambda for the compute. We're going to be using it to simulate the complex hellscape that is Doom. Now, I did mention that Doom was made in 1993, and because of that, it runs on MS-DOS. I did reach out to AWS to see if they would support MS-DOS for Lambda, but it's not currently on their roadmap. However, I did say that Doom had been ported to everything, and it is quite likely that Mozilla made both Rust and WebAssembly solely so that they could play Doom in the browser. So we're just going to piggyback off that. We're going to start with RC, we're going to augment it and fix some bits using Rust, we're going to cross-compile it to WebAssembly, and it runs on Node. And better people than me have explained that, so I'll put a link there. But you do need to know one technical detail, which is the interface we get back from taking this approach, because it informs all of our architectural decisions going forward. First of all, we get a method that we have to call about 25 times a second, and that's just to tick along the game loop. The old version of Doom, you know, would do that at 100% CPU, but modern hardware being what it is, we can do that and we have some room to spare. The next thing that we take responsibility for is capturing key events and forwarding them into Doom because it can't access the keyboard. And similarly, Doom can't touch the screen because JavaScript doesn't really have hardware drivers. And so it becomes our responsibility to be told where in memory Doom has rendered a frame and to take that frame and show it to the user. So we're running our game with Doom, but if no one can see it, are you truly playing it? So let's use S3 to get our screen. Now, not to get too technical, but S3 has get after put semantics. This means that when you write a new file to S3 or you update to a new version of that file on S3, the client only sees that once the put has been fully committed. You cannot stream a file through S3, you can only stream it off S3. And this would be a huge problem, except that in December 2020, AWS decided that it would be easier to make S3 strongly consistent than continue to try to explain to developers what eventually consistent meant. And this is great for us, because it means that when we get our buffer, we just render that to S3. When we get the new buffer, we just overwrite that file. And if we have a client that is constantly getting that same key, like a old school analog film, lemmings, like a lemming and an old school analog film, we will create moving pictures. So we have our screen, we have our compute. What about the keyboard? Well, DynamoDB, obviously. So how would we use DynamoDB to solve this problem? Well, DynamoDB, unlike quite a lot of databases, can be accessed solely over HTTP, which means that you can access it from the browser and the Lambda. So, and bear with me here. When the user presses the key, we will detect that in the browser. The browser will then write that key event directly to DynamoDB. Now, on the other side of the cloud, every time Doom ticks into the next loop, we will scan our DynamoDB table to get all of the key presses that we haven't processed yet, which we will then forward into Doom, and then we will delete those keys in the S3 data and the Dynamo database to mark them as pressed, and our man will do a little wiggle. So our Triforce is complete. We have Lambda running the compute. We have Dynamo being the world's most abstract keyboard driver, and we have S3 being the screen. And so I'm going to follow no one's advice and attempt a live demo, and I'm going to shout because I've got to put the microphone down. So let's have some fun. Rule number 1, never ever put a live demo in your thing. So I'm going to start our Lambda, kicking it off. And now I'm going to go to our local Dynamo client, and we're going to be loading this image every second. And I'm pressing keyboards, and look at that. We are playing Doom serverlessly. I am so bad at Doom. I really regret picking it as the game that I was going to do all of this with, but you can't knock it. We are playing Doom, and just to prove I've got nothing up my sleeve, we have a look at S3. We can see our little frame here. If I just download that.
Can you show network?
Open. Can I show the clock? Look, there we go. That's a Doom frame, Doom frame. And if I hit some buttons, and the keyboard's off now, we have a look at our Dynamo database. Boom. There are our unprocessed keyboard events. There we go. We have serverless Doom. You guys are really undermining the other half of this presentation. Because what I'm going to say now, I'm going to say regardless, it's not great. The experience is more seconds per frame than frames per second. And this is because, although AWS would have you believe that S3 is infinitely scalable, if you want to get a 429 out of it, read a file continuously while you continuously delete and update it. It tops out about 5 frames per second, which is, you know, substantially worse than MS-DOS. Also, I mean, this is more for me than for you, the keys are very sticky. There's a huge latency between key down and key up, which makes dodging the spawns of Satan very hard. And this is for kind of a similar reason. When you start optimizing for Dynamo, one thing that you learn is to not scan the table all of the time. And if you're going to insist on doing that, don't put loads of deletes between, which completely destroys the cache. Lambda, fine. This is unremarkable if you consider that your average Lambda runs on a CPU which is about 150 times more powerful than the machines that Doom was written for. But you know, it does have one problem, which is that after 15 minutes longest, AWS will come and terminate our game of Doom, which means that our version of serverless Doom is only really suitable for speedrunners. But hey, so, like serverless Aora, we will iterate to a version 2, but this one won't be terrible. That's a really bad Aora joke for anyone. Okay, so let's solve our input problem. The first rule of serverless and Lambda is be functional. That means that your average Lambda, you give it a payload, it runs a function. You know, it might cause some side effects in your infrastructure, and it may even respond to you, but you know, it does its own business. You don't interfere. But we want to talk to our Lambda while it is running. We want some two-way communication going. AWS actually gives us a wealth of services, serverless services, to allow us to communicate between decoupled applications. We can knock 2 of these out of the running to start with because they are push-based. Both SNS and EventBridge expect to be able to invoke their own Lambdas, which means that every time you press a key, we start a new game of Doom. It's not great. Kinesis and SQS, though, they are poll-based. And although it's a very weird pattern, there's no particular reason why you can't poll these from within a running Lambda. So I tried that. It's really slow. It has like an end-to-end latency of about 3 to 5 seconds, which is worse than just scanning a table all the time. But in the serverless game, you learn to think outside the box. Introducing AWS IoT Core. It's underutilized. I absolutely love this service. For those of you who don't know, it allows serverless real-time communication between doorbells, chargers, thermostats, and less serious things like egg cups, forks, and belts. And if you can connect your belt to the cloud, then there's really no reason why you can't use this to allow two-way real-time communication between Lambdas and the browser. And actually, semi-seriously, this is a criminally underutilized service. You can use this to implement things like the broadcast pattern, cancellation tokens. You can even use it to connect a debugger to a running Lambda, but nothing as serious as that. This is not a serious talk. We're just going to use it to allow our Lambda to handle our browser events. So we have real-time communication. Our keyboard is snappy, which is unfortunate because our graphics are not. So let's solve our graphics problem. Now, when I was mucking about trying to get this to work, there was a short period of time when it looked like AWS was going to introduce a feature before I needed it rather than afterwards. And if you take anything from this talk, it's that when an AWS blog post giveth, the quota page will taketh away. And yeah, it turns out that the streaming responses from Lambdas, which we could have used to just stream our game back to the client, are limited to 20 megabytes or 6 seconds of Doom, which is, you know, even worse than our current 15-minute limit. For those of you who pay attention to the business news, though, you might know that Amazon, and thus AWS, own 2 huge live streaming services, Twitch and Prime Video, which famously does not run on a monolith. And because of that, they have white labeled a lot of this tech. they have white labeled too much of this tech. But once you have read through 90 pages of documentation, you will come to learn that the correct service for streaming, ultra low latency streaming in AWS is AWS Elemental Live. But because AWS love to kick me when I'm down, we will find out that the definition of ultra low latency is 3 to 4 seconds, which is worse than just saving pictures to S3. However, we will endeavor, and buried in a completely unrelated service is Amazon Kinesis video streams, which is designed to capture CCTV footage and pass it to recognition for technical demos, is a serverless implementation of WebRTC, which, if you can see from here, is low latency. And we all know that low latency is about 100 times lower than ultra low latency. So we have our problem solved. I appreciate that not everyone is excited to see WebRTC. That's because you may not know that WebRTC is a technology with a terrible logo that was developed by Google because they were so frustrated that everyone was using Zoom and no one was using Hangouts. We are going to start a video call with our Lambda, and this is going to be fine. So, one last thing. Oh, actually, I just want to talk about how stupid this idea is and how we're going to get through it in any case, because WebRTC is really a browser-based technology, and therefore to get it to work, I had to take the embarrassing step of having my Lambda use something called Puppeteer to start a headless version of Doom inside the Lambda to then run the rest of the JavaScript so that that could run Doom, so that I had access to the browser API to stream back out Lambda through WebRTC. And also, while I'm ranting, I would like to give this page the highly contested, most useless page in the whole of AWS's documentation award. Known issues and workarounds, workaround none. Fuck's sake. Anyway, back to work. Our Lambda is going to die after 15 minutes, and I'm not good enough to complete Doom in 15 minutes. However, we are saved by, I don't know, maybe the laziness of the WebAssembly spec, who, when confronted with trying to work out how to share variables and types between every programming language that can compile to WebAssembly, went, sort it out between yourselves, find it out in the car park, I don't care, here's an array of bytes. And this is really useful for us, because it means that the memory of a WebAssembly program in JavaScript is just an array. And at any point in time, you can clone this array, and then later you can re-inject it into memory, and your game of Doom will just snap back into the state that you took that clone from. This is saving and loading the state of the world that you're playing in. And because Lambdas can invoke other Lambdas, when we get to the end of the life of our Lambda, we simply save the state, invoke a new Lambda, hand it the state that we saved, and it will pick up. And the TV is, AWS is silencing me. That's all I can say. Does anyone know what I have to press to?
I'm going to come and solve that for you.
Hey, I'm going to carry on. Anyway, so essentially we're going to start a new Lambda with the old state, and that Lambda is going to snap back into the state of the Lambda that we left off on, therefore allowing us to just hand over the game, and what I'm going to describe as smoothly, but you know, maybe there's some room for improvement. So our Triforce, what does it look like now? Well, still got Lambda on the compute, but our S3 bucket has been replaced by a video call using interactive video streams, and our keyboard has been replaced by IoT Core, which is going to be forwarding on MQTT all of the events. Do actually have a bit of S3 because the state is bigger than the asynchronous payload, but oh God, guys, this is fun, isn't it? It's ironic because I've got 2 live demos, but it's really the slides that are letting me down. There we go. Hey, which is ironic because I've really committed to this whole triangle thing, so I'm going to ignore the bucket for now. Really, just to completely tempt fate. Technical things, we are going to see what this version looks like. And once again, I'm going to throw down the mic. and just shout at you all. Okay, right. Nothing up my sleeves, blah, blah, blah. We start our Kinesis video stream version. We are testing, we are running, and I'm going to change the client. So, joining our video call. Come on. And we are playing Doom. And I reckon, hopefully, it's still going to look smoother. I appreciate you are watching a video call. Oh, look at that. Look at that. The keyboards are working. I love your enthusiasm. Unfortunately, I've got to play it for another 40 seconds because I'm going to demonstrate that it doesn't die after a minute, which is the lifetime of this current Lambda. But I might die after a limit because, as I mentioned, I'm actually quite bad at this game. Anyway, so I can see it's ticking along. Well, I'll tell you what, I'll just prove now by joining the video call here that it is real. I am playing on a video. And if we have a look at the MQTT client, when I hit some keys, they appear down on the keys. And 53, 54, 55. Okay, so I didn't say it was as smooth as possible, but our Lambda has just died, and we have just handed over to a new Lambda. Well, okay, that genuinely is the end of my live demos and tech problems. Ha ha ha. Sorry, I have to clap again. Exactly, use this one to battery. So let's talk about the one thing that no one likes to talk about when they're trying to serve you serverless. Honestly, even if this had been on an EC2 machine, I wouldn't have been able to tell you how much it costs. But I've got a spreadsheet involved. I reckon it's about 5 cents for 15 minutes or a quarter an hour, which is, you know, good value in any arcade. Now, we don't have to stop there. I will stop there. Do not worry. But at the moment, we're playing this sort of global instance of Doom, but staying in the serverless land, we can wrap that with a bit of Cognito, some API gateway, some Route 53 to get some user management, and then obviously we can throw in some step functions, maybe some event bridge, so that we can manage that game restoring flow. But why stop there? Doom has an amazing networking stack, which we can re-implement, maybe using a bit of SNS. SQS is the real test of how well you know your AWS icons. And because we're doing that, we'll want some visibility. So we'll put some CloudWatch in there, maybe some time stream. Hey, we can throw in some Athena, and we can be the first people in the world to attempt to use QuickSight in production. And then finally, we will have an architecture diagram worthy of an AWS blog. And assuming that they don't send me a cease and desist, you can play it here on my GitHub. But to end the talk and answer a very important question, AWS serverless services? Sure, you can play Doom on it.